Okay, homework status. Oh, is it bolted? Check, Myra. I think it's open. Who's that? खुला था लॉक नहीं. Okay, Shambhala all correct. Ashwik all correct. Harsh little bad, but not very bad. Parmanand, you didn't get 2 questions or what? Okay, and Sohan all correct, good. Sara all correct. Arjav good. Pranavi, you got 3 wrong. We will have to look into it.
Yes, sir.
Ishani, you also. Nihal got 2 wrong. Actually, pretty good accuracy whole class, except for Arihant. Arihant, what happened?
Sir, I don't know. But sir, I've done 14 questions and it's written 13.
Myra, you got all correct. There is nothing much to do. Bhavya, where were you yesterday?
Sir, I kind of went to the library at 4 o'clock and stayed there until 8.
Oh, you forgot about the class. By the way, Miraya was asking, you're not coming to Kung Fu either. Acha, this month you are on break. Oh, okay.
So did you share the answer key?
I'm sharing right now. Wait. I have copied to the assignment. You can look there. I'm sharing on the screen also.
Okay, sir.
Myra, able to see? By the way, again, you already have the answer key. Shambhala, when are you coming back? You've been away for a long time.
Sir, 25th, I think.
Okay, so then you will meet me in June only. By the way, guys, you know, right? The week after next week is summer break.
Wait, summer break?
Look at the notifications, list of holidays. Look, May 26 to May 30 is summer break in the holiday calendar. 5 days, like that full week is off. And no homework also, at least in this batch, so no homework. For the other batch, for advanced math guys, there will be homework, but you guys in a way will not be in advanced math in June, right? So you will also have homework, but you will have a lot more time to do it. For you, it will be like due in July when you rejoin the advanced math. What homework? It will be long. It will have a lot of questions. I am planning a package of around 50-60 geometry questions in that.
Got 8 correct.
Okay.
Sir, I got all correct.
Yeah, Anish, I'm aware of it. Okay, tell me the doubts, please.
Sir,
Second one.
Sir, second section, 5th and 6th.
Will this batch be having any home?
No,
Sir, will
see,
the
Anish,
second
I will
batch-
see, but most likely no. But if at all there something small might be there. As a policy, like whenever this big breaks are there, na, summer break or Diwali break, generally I don't give homework. It's like break should mean complete
Okay.
no tension break. That's what the idea is. So most likely, no, I will see if required, I might give something small. Even if I give, it will be like not more than 20-minute work. Something which you can do on the day when you rejoin.
Okay, sir. Okay, sir.
But mostly no,
Yes, sir.
mostly no homework.
Okay, sir. Sir, section B, fifth one.
Pardon? Come again?
Sir, second part.
Sir, second one.
Sir, second question is.
Sir, part one, second question.
So first one, no doubt.
No, sir.
So
No,
part
sir.
two, you are saying second question, no?
No,
Ajay, you
part
said
one,
part one.
second
Sorry,
question.
I didn't hear you. Part 1 second. So how far from home was t equal to 4 second? That
Sir, you're not in the screen. Sir, you're in the wrong screen.
find how far from home the person was at t equal to 4. Who has a doubt?
Sir, Arihant.
Arihant, the equation of this curve was given
Yes, sir.
x square by 20 plus x by 10. I'm copying it. Okay.
Sir, y
Yeah,
is
sorry.
equal.
Y was fine. Now calculate
4 square by 20 plus 4 by 10.
which is 8 by 20 plus 4 by 10. Sorry,
16
16
by
by 20. What am I doing? Yeah, 0.8 plus 0.4, 1.2. Okay.
Sir, part two, fifth one.
Part 2, first one, Ishani.
Sir, fifth one.
Okay, Ishani is asking part 2, first one. So first I'm doing that. And then I will do part 2, fifth one. By the way, today full attendance is there.
Sir, why?
Yeah, I think. Because you guys don't seem to have too many doubts. So that will help me today teach you calculus. First time.
Sir, isn't that an advanced math topic?
It is, but it is very, very closely related to graphs. You need very good knowledge of graphs to understand it. Now you are at that level where you can understand it.
Sir, what is the meaning of calculus?
You will know.
Okay, sir.
average velocity between 0 second and 10 second. Okay. So Ishani, since it's velocity, we only need position. So where was he at 0 second? Look at the graph. And it's a straight line motion only. So -2 meter at 0 second. Then at 10 second, where was he? 5 meter. So what has happened? How much is the displacement? Forward, backward. So forward, you can either say 7 meter forward, or you can say plus 7 meter. Okay. So average velocity then is 7 by 0.7 plus is important. Okay. You either say 0.7 meter per second forward, or you say plus 0.7. Okay. Where did you get it wrong? Very clever. Okay, part 2, fifth one. Bhavya is asking anyone anything before that?
Sir, fifth one. Part of
Part
fifth
2,
one.
fifth one.
Yes.
Okay.
Sir, part of fifth one, right?
Oh, sorry, I copied wrong. Exact position at t equal to 13. Who has a doubt in this?
Very high.
Nehal, Bhavya, you also?
Sir,
Bhavya, which method do you want to use, Nehal?
Sir, y2 minus y1 by
You
x.
want to use the equation of line, so then list down this point.
Sir, 10 comma 5. I mean 5. Yeah, 10 comma
Yeah,
5.
10 comma 5, not 5 comma 10.
Sir, and then 15 comma 2.
So what is the slope?
Sir, the slope is 3
2
by,
minus 5 by,
sorry, minus 3 by 5.
right?
Yes, sir.
So equation is x equal to minus 3 by 5 t plus c.
Yes, sir.
Find c.
Sir, sir,
Hmm?
sir, 2 equal to minus 15 plus 3. Sir, minus 15.
Minus 9.
Yes, sir, minus 9 by that. Sir,
C
11.
is 11.
Yes, sir.
So x equal to minus 3t by 5 plus 11.
Yes, sir.
At t equal to 13, where is it?
Sir, minus. Sir,
Yes.
sir,
Which is-
minus 39 by 5.
Which is minus 7.8 plus.
7.8 plus 3. Sir, I got the equation wrong.
Huh?
Sir,
Yes, so C is 11. What is the problem?
sir, you got C is equal to minus 9 plus C.
Where?
sir, before C equal to
Oh, okay. Minus 9 plus 2. Okay.
Sir, 9 plus
Sorry, 2 equal to minus 9. Okay. Fine.
Sir, part 3.
Yeah, my bad. Part 2, which one?
Part 3, first one.
Arjo 6, you are asking. Arjo, see, Arjo, I will go back. I will not copy this because it is straightforward. Instantaneous velocity at t equal to 4. Now, t equal to 4, where is it, Arjo? Or wait, let me copy it. It is ah, anyhow, never mind. T equal to 4 is between which time? Yeah, and instantaneous velocity is asked. What is instantaneous velocity? Yeah, is it? Can we find it? Why can we find it? Because the velocity between 0 second and 10 second is constant. It's a straight line motion, sorry, straight line graph. So velocity is constant. So anywhere in between, velocity remains same. How much is it? Arjav, revise what happened in last couple of classes. Okay. Moving on. Next.
Sir, part 3, first one.
Part 3, first one. Okay, average velocity between 0 and 10. So where is he at 0?
Sir, 3 meters.
3 meters, right?
Yes.
And where is he at 10 seconds?
Sir, 10 meters.
So
Sir.
So how will you calculate the average velocity? Displacement, how much?
Sir, is it? Oh, displacement. Sir, uh, 0 seconds to 10.
Yeah,
3
average
meters.
velocity between 0 and 10.
Yeah, displacement by time.
So how much is the displacement?
Sir, displacement is 7 meters.
Forward, backward, plus, minus.
Sir, plus.
Time,
Yes, sir.
average velocity, 7 by 10, 0.7.
Point. Oh.
Okay.
Yes, sir. Okay.
Next. Next. Nothing.
No, sir.
Hmm?
No, sir.
Okay. Yeah. If you see, I'm giving
Sir, is this a question?
yeah. Equation of curve is given. It will, but that's little more advanced calculus, which also you. No,
Sir,
that
is
is
that a
integration. That is even more advanced.
sir? Is
We
that a
won't learn that in grade 8. We'll learn that in grade 9.
sir?
Area
Is this sir? Is the second figure a constant?
Yeah, second figure I have given equation of line. It's a line, right? Question is find instantaneous velocity at t equal to 2 seconds for both, in both cases. In both cases. Okay, there are two cases given, case 1, case 2. In both, you have to find instantaneous velocity at t equal to 2 seconds. Mind it, here I have given equation of line directly. So rather than giving points, I have given equation of line. So
It's a that is 0, 0, right? First, that's started.
yeah, doesn't matter, but yeah, this is 0, 0. Although it won't matter, okay. I asked instantaneous velocity, not average velocity. At t equal to 2. I asked average velocity, sorry, instantaneous velocity. That's not correct. First case, it's wrong. Second one, correct. Both wrong. First wrong, second correct. Both wrong. Both wrong. First one wrong. I have got answer from unknown number. I don't know who that is, but it's wrong. Whoever this Madan Mohan Reddy. The second is correct now. Second is correct, first is wrong. Okay, guys, so first of all, it's really stupid answers is what I got. Online people don't even know what they are doing. That was
Sir, 1 second, sir. Upside there.
I've got some really stupid answers from everyone. Okay, I don't think online anybody is interested in sending.
Sir, can you write your number on the board, sir, or send it in the chat? Because like I don't have my phone, I'll send it from my friend's phone.
Sarah, second one is fine, but like no logic.
And just see the answer is 12 man.
Second one is fine, but zero logic.
Okay.
Harsh, both completely wrong. I don't know what to do with you guys because I doubt you will. I just said few moments back that I feel you are ready to understand calculus, but it seems you are ready to understand nothing. Oh. What did I tell you about instantaneous velocity other day? What is it? Aviram, you leave it. It's beyond you, but others at least can. Hmm? Hmm? Pardon?
Sir, I said.
It will be? Huh? Any given time at a no, Rehan, guys, stop sending. Nihal, it's wrong. Any given?
Equal at any given time is a straight line motion. Uniform.
Yeah, that is okay, but what is the meaning?
Clear, flat, exact.
Direction. Okay, online, let's check. Rudransh, do you remember what is instantaneous velocity?
So like the velocity at a particular time.
Okay. Sohan,
Sir, it's like the rate at which the speed is changing with respect to the uh, direction as well as
no,
time.
it's not that complicated, and it's not rate of change of speed. Anish,
Sir, the
Anish, you're not
sir,
audible.
the speed with the direction at a particular moment.
Yeah, that is
Sir, can you hear
fine.
me now?
I can.
Sir?
I can. I heard
Sir?
you. It's fine.
Okay, sir.
Okay, first one. At t equal to 0, where is the particle?
Says 0.
And let's say at t equal to 2, where is the particle? 8, 2, comma 8. Okay. If I do this now, how much is displacement? 8 meter. Time.
2 seconds.
And then if I do 8 by 2, what is this 4 meter per second?
Sir, velocity.
It's not velocity.
Says speed.
No, it's not velocity or speed. It is average
Average
velocity. Now, why am I not calling it velocity? Why am I calling it average velocity?
This is not the speed of the particles traveling in all points of the earth.
Yes, Bhavya. Others, I just now refuse to call this velocity. I called it average velocity. Now let's do the same thing here. Let's say at 0, how much it is? X equal to 1. So 0, comma 1. At t equal to 2, x is 3. So 2, comma 3. Now here if I do displacement upon time, which is 3 minus 1 upon 2 minus 0, which is 2 upon 2, 1. What is this 1 meter per second? Average velocity.
Sir, it is
Also, instantaneous velocity.
It is also called velocity. Silent, Bhavya. Now this guy, first guy, I said this is average velocity. Second guy, I am calling 1 meter per second as average velocity. I am calling it as velocity as well. Second time, I am not refusing to call it velocity. First time, I am refusing to call it velocity. I am sticking to average velocity only. But second time, I am calling it average velocity as well as velocity. Now,
Sir, because it's constant. Sir, because it's constant. The second one.
Aryan, did I ask you? Okay. So Ashwik, why do you think second case I am saying it's average velocity or velocity both, and in first case I am refusing to do that. Okay. online someone? What about Shamla?
Sir, I didn't get your question. Could you repeat it?
Leave the class. You didn't. Where were you when I was asking?
Sir, I'm having network issues.
So catch up to recording then in that case. Bye. Okay. So next then Sarah.
So is it like for the first case, the speed is the velocity? It's not like constant, and the second case it's constant, so the average velocity can also be velocity.
Okay. Sohan.
Sir, in the first case, it's a curved graph, which means that the speed is changing. And then in the second case, it's a constant speed because it's a straight line.
Okay. So broadly, the people who spoke, they are right. Here, the speed is remaining constant throughout. So if the average speed or average velocity is coming 1 meter per second, and we are saying that throughout the journey speed was same, that means anywhere in the journey, be it 1 second, 2 second, 3 second, it will come out as 1 meter per second, and average of all that will also be 1 meter per second. Ishani. But in this case, what is happening? What is happening? So average velocity is coming 4, all right. But what is happening to the velocity? It is continuously changing. So if the velocity is continuously changing, what does that mean? Can you tell the velocity at a particular time here? Can you say that at 2 seconds it was 4 meter per second, or it could have been something else as well? At different times, it is different. Yeah.
Using the equation of the line, I said x is basically y is equal to mx plus c. Then I have everything p square. So then I put it like that and I got 4, but then I realized that p square is going to change every time the second changes, so I can calculate this.
Yeah. So basically, we don't know. Speed is continuously changing. So average speed, average velocity, though I can calculate. But exactly at 1 second, exactly at 2 seconds, exactly at 3 seconds, what was the velocity? I can't calculate. Okay. So for now, average velocity is calculatable here, but instantaneous velocity is not calculatable in the first case. Is that clear? Hello?
Yes, sir.
Sohan?
Yes, sir.
Because it's very important to understand that part. So now where does Newton come in here, like, or calculus come in here? Calculus is the field of math which was invented by Newton. Newton was able to solve this problem. He was able to teach, or you can say figure out, how to calculate velocities at different times. And the tool which he used to do that is called imagination. He used a bit of imagination to do this. Okay. So next thing we need to learn is that how Newton used his imagination to solve this particular problem. Okay. And it was a major breakthrough in field of math and physics, because a lot of things which you do in physics are solved with help of calculus. So the current advances which you see in physics, chemistry, and all, a lot of it goes back to discovery of calculus. Almost all of it, what you see today. AI has calculus at its heart. You will be surprised to know that. It is very related. AI is anyways math. AI is proper math. The technology, the core AI technology is all about math. And as I told you, the math which is most involved there is calculus. And in fact, once you understand this graphs, right, AI uses one algorithm whose name is gradient descent. Gradient descent. GRADIENT, gradient descent. It is the most basic algorithm of AI. So AI has multiple algorithms, like gradient descent is one of them. Support vector machine is another neural network is another. There are different ways AI basically works. Yeah, descent means descent here. DSCNT. Yeah. So still, and there are like gradient descent is considered to be one of the most easy or one of the basic algorithms of AI. There are of course much more advanced algorithms of AI as well, but still about 60-70% of AI uses gradient descent only. So if you understand this well, you can even understand gradient descent. You can understand the AI which you will probably learn in your college. But before that, this should be very clear that right now what problem Newton or we are trying to solve here. Right now it looks impossible to find velocity at a given point. Average velocity, yes. But if a curve is there at a given time, finding velocity looks impossible. Yeah, but how will you find that? So look at it. How did Newton solve this problem? He again drew two graphs. We will take the same two. I am calling them like this, or you can say x equal to t plus 1 and x equal to t cube means the same thing. Okay. Now what Newton said is line graph it's possible to find. Instantaneous velocity. Okay. Curved graph.
Yes.
It's impossible
Sir,
to find.
did he imagine to convert the curved graph into a straight line graph? Like into a line graph?
Not exactly. I will come to what he imagined. So what he said is that if you zoom into a curved graph, actually curved graph is made up of many straight lines. So he said that in a straight line graph, it's possible to find. In a curved graph, it's impossible to find. But what if I look at curved graph carefully? Any curved graph is made up of many straight lines. Look, any curved graph can be broken down into straight lines. So multiple straight lines with different what? Yeah. If you, let's say, if you take now, now I'm making a bigger graph for you to understand.
Sir, is it multiple lines with different slopes?
Yes. And let me make an exact graph. I will use grapher. This is the graph we were after. So I'm using a more fancy graph now. I think it helps if I remove the grid. It will be better.
Sir, we are not able to see the 8-meter
Wait,
mark.
now wait, I am. Wait. You're not able to see because I have not shared it. Now I'm sharing. There will be infinite straight lines. Imagination.
Sir,
Okay, so what he said is that there are a graph, if you zoom in, you will realize that it is nothing but made up of infinite straight lines. Do you understand what he means by infinite straight lines?
sir,
Yeah.
isn't it a straight line if it has infinite straight lines?
Pardon?
Isn't it?
No, it is not. Reason is a single straight line. For example, like if you draw a single straight line, let's say, where you will get it slowly, just wait. Just hold your horses, that's what I would say. See, you are right, Arihant. Arihant, you were saying that, right?
Yes, sir.
So Arihant, there is a difference. Even a single straight line can be broken down into many straight lines.
Yes, sir.
But all of these straight lines have same what?
Oh, same course.
Same slope.
Yes, sir.
Like it's not like that one straight line is more steep as compared to others. All are equally steep. So same slope. Here, what is changing? Some straight lines are less steep. Well, there are others which are more steep, and then there are further others which are very steep. Yes or no?
Yes.
Hello. So he is saying a curve is made up of multiple straight lines, but those straight lines, all those straight lines which a curve is made up of, all of them have different slope. Can you see slope? How can you predict the slope of a line? By looking at its steepness. More steep line means more slope. Less steep line means less slope. Example I can give you. You know how to find slope. Let's say this is one line. The coordinates are 0, 0, and here it is, let's say 3, 2. On the other hand, compare it with something which is really steep. 0, 0, and here 1, 4. This is less steep. See the slope here. 2 minus 0 upon 3 minus 0, 2 by 3. Slope here by 1 minus 0, 4. So steeper the line, more the slope. Okay. Hello. So what he is saying is a curve is made up of many lines, and each line has a different slope. So far good?
Yes, sir.
So far good? Now comes the real magic, the imagination which I was talking about. So we were trying to find the velocity at t equal to 2, right? Yes or no? Here actually 2 has gone out of horizon. So I will I'm recopying the graph so that 2 does not go out of horizon. Wait, Bhavya, hold your horses. I will give you a chance to work it out, not just you, like everyone. So now what Newton says is that this is a y equal to x cube graph. What he says is that even at t equal to 2 seconds is somewhere here, even this part of curve, which is corresponds to t equal to 2, must be made up of a small straight line. This part where we are around t equal to 2 seconds, even this part of curve would be made up of a small straight line, right? Now this is where he was clever and he used imagination. He said that there is a part of this line which starts from being slightly less than 2, and when the line ends, we are at a point which is slightly I'm making it a little bigger so that we actually can go beyond it. So this is not coming straight, but okay, like this would be better. I hate my room.
Sir, could you come up again? Your voice was breaking. Like the slightly greater than 2, that's
I
what
was
I
saying
mean.
that he said that even when it's t equal to 2, the part where t equal to 2 happens, this is where t equal to 2 is happening or no? Hello? Even
Yes.
this part of graph is made up of
Yes.
a straight line.
Sir.
A straight line which starts just a little before 2 and ends a little after 2. Getting? Hello?
Sir, what if it is a smaller straight line?
It doesn't matter. I will come to that because that's a very good question you are asking. There is some straight line, right? So what he said is that this graph, when time becomes 2, then also this graph must have some kind of straight line, which is starting just before 2 and just after 2. Now look at it. This is where he used imagination. Anish. Now, when we say just before 2 could mean 1.9 second and just after 2 could mean 2.1 second. Hello?
Yes, sir.
So in that case, this straight line is 0.2 second long. But Anish just now asked, what if it's a smaller straight line? So he said that, okay, if it's a smaller straight line, it could be 1.99 to 2.01. If it's an even small straight line, it could be 1.999 to 2.001. We don't know. Then he said that it can be 1.99 and 2.0001. So there is no limit to it, right? That how small this can get. Hello?
Yes.
Yes, sir.
And getting, I am taking your point here because line can be very, very small as well, right?
Yes, sir.
Depending on what time you are starting, what time you are ending.
Yes, sir.
Yes, sir.
So what he said is, I don't care about 1.99 or 2.001. He said, I don't care. I will use algebra. He said that this point, which is just before 2, will be 2 minus delta. And this point, which is just after 2, will be 2 plus delta. Where what is delta? Something unimaginably small.
Where is that the sign for delta?
Hmm?
Where is that the sign for delta?
Yeah, that's delta. This is called
Sir, I got
delta.
confused. Sir, I got confused with square root.
Sir, I
Square.
thought it was an S, then I thought it was a square root, then I
No,
thought
this
it
is delta.
was
Okay. So Newton said,
Yes,
what?
sir. I also thought in that sequence.
So can't it get smaller by
Hmm?
saying, so can't it get smaller by saying 1 minus delta?
No, why will you say 1 minus delta? You are close to 2. So this line should pass 2. Okay. This line should pass t equal to 2 seconds. And it should start from something which is slightly less than 2 and end at time slightly more than 2. But how do you define that slightly? Array, don't say that. Delta is we don't know what, but it is something unimaginably small. No, you can take equal, right? It will still be a straight line if we take equal. So he's taking equal only. But what is the value of delta? He's not commenting on that. He's saying delta is something extremely small, unimaginably small. Now you keep on using your imagination how small it can get. I don't care. It is as small as possible, but I don't know how small we can go. So that's why he's saying unimaginably small. Okay.
Sir, is there any rule that 2 minus delta and 2 plus delta, in that the delta is same?
Yeah,
Or it
it
is
is.
like
You can take it
somewhat of the
same,
same
right?
value?
He is taking it same.
Oh,
There
okay,
is
sir.
no rule. He is making the rule. He is saying that I will take it same, slightly less than 2 to slightly more than 2.
Oh, okay, sir. Sir, like I was thinking, what if some portion was like less above the two second point, and some portion was like little bit more
No, he
down
is
of the
taking
2
it
second.
like that equally less and equally more. He is taking
Okay,
it
sir.
like that because there is no harm in taking it like that. What I want is a straight line which is passing t equal to 2 seconds. So will that affect that if he takes equal? Hello?
No,
So
sir.
now it becomes easy. Find the slope of this line. And finding slope of this line is not hard. This point you can find. This point is 2 minus delta comma. Remember the curve was y equal to x cube. So if x is 2 minus delta, y is 2 minus delta whole cube. See, this is the curve, right? The equation of the curve. So if you keep x as 2 minus delta, the x coordinate as 2 minus delta, the y coordinate will be, right? What are the coordinates of this point? X coordinate and y coordinate. So now you have got the coordinates of the line, a very small line which is passing through t equal to 2. You know how to find slope because slope gives you velocity, right? So slope is 2 plus delta whole cube minus by 2 plus delta. Okay. So that gets 2 plus delta whole cube. This is 2 plus delta minus 2 plus delta. Okay. So 2 plus delta whole cube minus by 2 delta. That's the slope of that line, which is passing through 2, and it's a line. Now apply 2 plus delta whole cube minus 2 minus delta whole cube. A plus b whole cube I taught you, right? And
Sir, you taught a plus b whole square.
don't worry, if I didn't teach now, you can calculate 2 plus delta whole cube. You can write it as 2 plus delta whole square into 2 plus delta, which is 4 plus delta square plus 4 delta into 2 plus delta, right?
So we can
Which
use
is
a square
8
minus
plus 4 delta plus 2 delta square plus delta cube plus 8 delta plus 4 delta square.
So we can use a square minus b square.
So delta cube, yeah, a cube minus b cube. It's not a square minus b
No,
square.
like, sir, you can take 2 plus delta common and then,
2 plus delta is not common.
oh,
This is delta cube plus 6 delta square plus 12 delta plus 8. This so you can do. Minus 2 minus delta whole cube also you can calculate. Now when you calculate 2 minus delta whole cube, I will tell you what it will come. It will come delta cube. Sorry. Minus delta cube. Okay. Plus 6 delta square minus 12 delta plus 8. This is what you will get if you do 2 minus delta whole cube. I have done direct calculation here. Whole thing divided by 2 delta. Okay. Now I'm copying this same thing on the next page. Okay, so from here, this was minus delta cube. I don't know why cube didn't get copied. Okay, and this was 6 delta square. Okay. So we get delta cube plus 6 delta square plus 12 delta plus 8 plus delta cube minus 6 delta square plus 12 delta minus 8 whole by 2 delta, right? This cancel, what do you get? 2 delta cube, 24 delta by 2 delta. Now take 2 delta common. Delta square plus 12 by 2 delta. So you get delta square plus 12. Getting? So slope
Sir, can you go to the
of
previous slide?
line, no, passing through x equal to 2 is 12 plus delta square.
sir, so
Yes.
whenever you have delta, you can't get a numerical value.
Array, let me complete. Wait. No, what was delta? What was delta? Something very, very small. Now, if there is something very small, just like 0.1, example 0. Then delta square, what does it do? It makes it even more small or no? Yes or no? So that means if delta is very small, delta square is even more small.
Yes.
So something very, 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 very small, when you compare it to 12, it is negligible. 12 is very big. So basically, the answer to this will come like something like 12.000000. Infinite zeros after that one,
Yes.
which is, you can call it 12 or no.
Yes.
So that's it.
Sir,
Sir, then what's the point of delta if you're ignoring it anyway in the end?
Pardon?
So what's the point of delta if you're ignoring it anyway in the end?
So that's how he said
Sir?
that for a y equal, y equal to x cube at t equal to 2 seconds or x equal to 2, the velocity will be 12, or slope exactly at t equal to 2 will be 12.
Sir,
Yeah,
sir, you said that delta is the smallest thing possible. So how is delta square possible?
it is not totally accurate. But tell me one thing in the world, one thing which is totally accurate, one measurement. If your car odometer says you are driving at 60 kilometers per hour, are you really driving at 60? Or it could be 60.1, 60.01. This is 12 point infinite zeros 1 is more accurate than anything else in the world. So it is accurate.
Sir,
Sir, how does d square exist?
Hmm?
How does d square exist?
isn't it delta square?
Wait, one at a time, Kunal. Yeah. Hmm. Yeah. Yeah. Somebody was saying something.
Sir,
Sir, if delta is the smallest thing possible, then how does delta square exist?
In theory, it can exist, right? Smallest thing possible can have a square or no.
Yes, sir.
What is stopping the smallest thing possible to have a square?
Like,
Sir?
it invented numbers, but
Sir?
any number that you don't know the square root of minus one. So this is not that bad.
Yeah, pardon?
Sir, what is the use of delta if we like ultimately ignore it in the end?
How else would you have come to this conclusion?
So can't we try with using x or something like that?
You can choose some other variable instead of delta if you. But still, it should be very, very small.
Sir, but doesn't delta have like a certain value?
No,
Sir, but like it's supposed to be less than 0.00 something like that.
delta is very small. Now you keep imagining how small can it get.
Sir, how did Newton come up with the sign?
Delta, he just made the d and then extended it like a square root. Simple.
You're asking how did Newton come at this, arrive at this?
No, sir, he asked about the sign.
What sign?
By general knowledge. By general knowledge.
Okay, guys, we have overshot by a lot. I don't know you realize it or not. We are close to 7:30. We'll continue what Newton did after this.